Hello students, very good morning to all. Today we are going to talk about the very important topic in the electrostatics, that is the electric charge. Let us discuss about this electric charge in detail. Most of the objects in the universe are made up of atoms, which in turn are made up of the protons, neutrons and electrons that we know very well. And these particles have some mass as an intrinsic properties of the particle. That is a very important property. Similar to that, charge is also a fundamental and intrinsic properties of the particle. So that the electric charge is a basic physical properties of the matter that we know very well. See, charge, there are two types, positive charge and a negative charge. And here see, it is a positive charge and this is a negative charge. And here we have given the arrow mark. So arrow mark represents what? That represents the electric lines of force. The electric lines of force, it's a collection of that electric lines of force with that nothing but it's electric field which are surrounded each electric charges. So the electric lines of force which are coming out from the positive charge and the electric lines of force which are coming towards the negative charges. That I clearly explained in this diagram, you can see. So electric lines of force is coming out from the positive charge, electric lines of force is coming towards the charge, negative charge. Right, this electric charge is a property of the subatomic particle that causes it to experience a force when it's placed in an electromagnetic field. So what will be the magnitude of the charge? That magnitude of the charge, that is nothing but it is a 1.6 into 10 power minus 19 coulomb. Actually, we are having two types of charges, positive and negative charge. So what will be the positive charge magnitude? It is a plus 1.6 in 10 power minus 19 coulomb, means protonic charge value is a plus 1.6 10 power minus 19 coulomb. What is the electronic charge? It means negative charge. That value is a minus 1.6 into 10 power minus 19 coulomb. So the proton and the electron, both the charges are same in magnitude wise, but in sign wise, both will be different because of the positive and the negative. Right. So now let us discuss about the characteristics of the electric charges. So first and the important characteristics of the electric charge is the quantization of the electric charge. You know what is charge? Charge, there are two types, positive charge, negative charge. The magnitude of the charges are 1.6 in 10 power minus 19 coulomb. For proton, it is plus 1.6 into 10 power minus 19 coulomb. For electron, it is minus 1.6 into 10 power minus 19 coulomb. That is okay. So now, if you are having the 10 number of electron in a particular place, what will be the total charge? You have to use this one. Q is equal to N, means quantization of the charge, means it is a product of the number into electronic charge. Right. If you have the 10 number of electron in a particular place, means the 10 into 1.6 into 10 power minus 19 means 16 into 10 power minus 19 coulomb of charges will be present in that particular place, which indicates that the total charge value is nothing. It is the integral multiples of this value, 1.6 in 10 power minus 19 coulomb. Right. So one important point. See, if you have the only one electron, means that the charge, you know, very 1 into 1.6 into 10 power minus 19 coulomb means 1.6 into 10 power minus 19 coulomb. Right. If you have the two number of electrons in one particular place, means that is 3.2 into 10 power minus 19 coulomb. right? Okay. The question is it possible to get the 2 into 10 power minus 19 coulomb? No, it is impossible, right? Means you have to get the total charges only in terms of the integral multiples of this value. That's all. Integral multiples of 1.6 into 10 power minus 19 coulomb only, right? So you have to remember this equation, and Q is equivalent to NE, right? Okay, so this is one of the important ones. And the next characteristic is the conservation of the electric charge. Yes, electric charges can neither be created nor destroyed. Means total charge in an isotonic system always remains constant. We can apply this conservation of electric charge in ordinary chemical equation like this. You just think about the hydrogen and water, oxygen, and you will get the water molecule in this. Just to balance this equation. So if you balance it, you will have to write this 2 and 2 here. Try to open. Now you think about the number of molecule, hydrogen molecule here 2, here 1 oxygen molecule. Okay, number of molecular aspect, that is okay. That 3 molecules becomes into the 2 molecule here. That is okay. Now you have to think about the number of protons and electrons, sum of the particles, fundamental particles. Now you think about the how many number of protons in this hydrogen. For single hydrogen, 1 proton. For one single hydrogen molecule, it has 2, so 2 proton. Here 2 times of the hydrogen molecules there, so 4 protons and plus 4 electrons. So 8 number of fundamental particles, sum of the proton and the electron. Here you see only 1 oxygen, I mean 1 oxygen molecule. So totally 8 number of proton, and I mean O2 means 16 number of protons, right? Yeah. (16) 8 plus 8, 16. Plus you have to add the electron number, that is what? 32. So totally 40 number of charges there. After the reaction, what you will get? You just think about the H2. O, hydrogen only 1 and 2H plus 1 and oxygen plus 8, and here 2 times of the water molecules. So 10 plus it is 10 and 10 plus 10 it is 20. 20 number of proton, like that is you have to add the 20 number of electrons, so totally 14 number of electrons and the protons. Right? See now there is no changes in the proton and the electron numbers between the reactions. Right? Okay, so that is why we are telling that this is a conserved, I mean charges are conserved. Right? Means the total charge in an isolated system always remains constant. Right? Okay, let me we can see the next one. It's an additive nature of the charge. Yes. It's a total electric charge of the system is equal to the algebraic sum of the electric charges isolated in the system. So you just think about the one small system like this. Inside it, if you have the 8 proton and 2 electron, and what will be the net charge of this one? 8 plus 2 minus. So 6 plus 6 means plus 6 is the net charge of the system. Okay. So this is the additive nature of the charges, right? So these are all the general characteristics of the electric charges. Based on these, we are going to discuss simple numerical problems. The first one, find the number of electrons in 1 coulomb of charge. See, just think about only 1 coulomb of charge like this. Your given value is only just what? Only 1 coulomb. Now you have to find out the total number of the electron for getting the total 1 coulomb of charge. And what we have to do? Just a simple, apply your equation, quantization of charge formula, that is Q is equivalent to NE. Just to make it, N is equal to Q by E. right? Q value, it is given, it is 1 coulomb. E value, it is a constant, 1.6 into 10 power minus 19 coulomb. Make it division, and you will get what? 6.25 into 10 power 18 means this much number of electron we need to get the 1 coulomb of charge. Right? This is a very simple problem. Like similar to this, we are going to see one more problem. What is this? See the problem number 2, that is when two objects are rubbed with each other. When two objects are rubbed with each other, approximately a charge of 50 nanocoulomb can be produced in each object. Right? Calculate the number of electrons that must be transferred to produce this charge. See here, now you have to consider the two objects like this. Before rubbing, there is no charges on the two objects. After rubbing, what will happen? You rub it and make the disc. Okay, you rub it. After the rubbing, what you will get? You will get the 50 nanocoulomb of charges on both the objects. The 50 nanocoulomb can be produced in each object. Right. Now, for producing this 50 nanocoulomb in each object, how many number of electrons must be transferred? That you have to find. Again, the same formula you have to use. You have to use the quantization of the charge, that is Q is equivalent to Ne formula. You can take once again. From this, you can write N is equal to Q by E. N is what charge here given. It is 50 nanocoulomb given. Substitute 50 into 10 power minus 9 coulomb divided by E, that is a constant value, you know very well, 1.6 into 10 power minus 19 coulomb. Make it division, what you will get? That value is around 31.25 into 10 power 10, which indicates what? This much number of electrons means 31.25 into 10 power 10 number of electrons should be transferred for getting the 50 nanocoulomb of charges in each object. This is a point, right? Okay, students, so like this concept and some numericals, we will discuss one by one in next videos. So thank you so much, students.